In this video we're going to be looking at functions. We're introducing functions and we're also going to have a look at function notation. Now a function is just a process that happens to a number. So our function or our process could be that we are going to double the number. And all that means is if we put a number into our machine, we double it, and we get something out of our machine. So if we put the number 5 into our doubling machine, then out we get the number 10. We can create slightly more complicated functions by having more than one step. We could have double, and then we could have add 1, and it works in the same way. If we put a number in, it goes through the first step and then through the second step until it comes out the end. So if we put 3 in, after doubling we get 6, and then adding 1 gives us 7 as our output. We can also work the other way. So if we had a function where we maybe squared a number and then we subtracted 2 and our function goes through, if we were told that the output was 34, we can work backwards and work out what the input was. So if we had to take 2 off of the number to get 34, the number in the middle must be 36, and if we had to square to get 36, the input must have been 6. We can also use algebra in each of these machines, and that's what we're going to be looking at. Functions is an algebraic approach to using these function machines. So if we were to put x into this first one, we would double it, and out we would get 2x. We would put x in the second one, we double it and we get 2x, and then we get 2x plus 1 as our final output. And in the final one, if we were to put x in the middle we'd get x squared, and at the end we'd get x squared minus 2. So that's what a function does. A function takes an input and does something to it to produce an output. It's a rule that given one number as an input produces an output. The output might be the same as the input, it might be different, as long as when it takes a number in, it produces something else. But we have algebraic notation for functions. Rather than drawing out function machines every time, we have a notation that we use to write functions in shorthand in algebra. And the notation we use for that is we choose a letter to go on our box. So if we had our box, that was doubling that we had before, and we had something going in and something coming out, we're just going to rename that. Instead of doubling, we're going to call it f, and we do the same thing. A number comes in and a number comes out, but f now is shorthand for doubling. And the algebraic way we write that is f brackets x, and the way we read that is f of x. F of x equals 2x. And what that says is f takes x and produces 2x. So whatever it takes in, it doubles. There is another notation as well, which is f colon x arrow 2x. In much the same way, f takes x and produces 2x. Both these notations are a shorthand for the function of doubling. For doubling, it's not that much harder to write double. But for more complicated functions, when we have squaring and multiple operations happening, our function notation gives us a quick algebraic way to write these. So let's have a look at a few examples and how we can use functions. We might have the function f of x and we've been told that it's equal to 3x minus 2. What we can be asked is to find different values of x. So we might be asked to find f of 2. And what that means is where we see x in f, we've replaced it with 2. So where we see x in the output of our function, the rule of our function, we have to replace it with 2. So we get 3 times 2 minus 2, which is 6 minus 2, which is 4. Another example, we might be asked for f of a third. We do the same thing. We substitute in a third into every value of x. So we get 3 times by 1/3 minus 2. 3 times a third is 1, minus 2 is minus 1. We can put any number we like in there. We could maybe put in minus 1, and we would get 3 times by minus 1, and then take 2. 3 times minus 1 is minus 3, take 2 is minus 5. We can have more complicated examples as well. We might have the function g of x, because there was nothing special about the letter f. We could also have g of x, another function, which is the square root of 5 minus x. We work in much the same way. If we wanted to work out g of 1, we plug in 1 instead of x, so we get the square root of 5 minus 1, which is the square root of 4, which is equal to 2. Or if we wanted to do g of minus 4, we put in minus 4, so we get the square root of 5 minus 4. That's equal to the square root of 9, which is equal to 3. We can also work the other way, and we might be given that f of x is equal to 2 plus 3x, and we're told that f of x equals 8, and we need to find x. In this case, we know that f of x is equal to 2 plus 3x, but f of x is also equal to 8. So we would do 8 equals 2 plus 3x, and then solve the equation. Subtract 2 from both sides, we get 6 equals 3x, and then that gives us a final answer of x equals 2. And what that tells us is that if we put 2 into our function, it gives us the answer 8. And we can check that by doing f of 2 equals 2 plus 3 times 2, which is 2 plus 6, which is indeed 8. That's just a quick introduction to functions and function notations. In the next videos we'll look at some mapping diagrams and some more specific terminology such as domain and range that we use to describe functions.